Hello, hello everyone. I am Mansoori Nayaban Sarfadi. I am studying Guru Gobind Singh Polytechnic Nasik. My micro project title is Miniature Circuit Breaker MCB for Switchgear and Protection subject. Objective to understand the component working principle of miniature circuit breaker and its advantage over traditional fuse. Content introduction, history and its use, function, construction of MCB, working principle, advantage, application, comparison, conclusion. Introduction for MCB. Thomas Edison developed the idea for a circuit breaker in 1879. Gradual Woods improved upon the design to invent the automatic circuit breaker in 90s. Cooter Manufacturing Company manufactured the first circuit breaker in Philadelphia in 1904. Function of MCB. There are two functions of MCB: switching function and second one protection function. The switching function are on-off condition and protection function is overload and short circuit condition. Construction of miniature circuit breaker. You can see the closer section view. First, incoming terminal, plunger, knob like a switch, solenoid, latch, outgoing terminal, bimetric carrier, bimetric strip, arc cutters holder, arc cutters, dynamic contact, fixed contact, die rail holder. Main parts of MCB: thermal unit and magnetic unit. The thermal unit sends the overload fault and magnetic unit sends short circuit fault. Parts of MCB: arc cutters, knob like switch. Parts of MCB: incoming and outgoing terminal inside of magnetic unit. Working principle of miniature circuit breaker. On-off position. The first diagram is on position and second one is off position. First one is contact are close and the second one is contact open. Closer look of magnetic coil. Flow of current like incoming the current inside the first bimetric strip in magnetic coil and flow of current. Arc formation, arc cutters. Comparison MCB versus fuse. Advantage over fuse. Easily identify the faulty zone of electrical circuit simply to resume supply. Better interface knob, electrically safer, more sensitive to current than fuse. Reusable, less maintenance and replacement cost. Application: home electrical panels, ground fault trips mechanism, lights, industrial application, heaters. Conclusion: miniature circuit breaker are more effective than traditional fuse. For better understanding, watch this short video.
of miniature circuit breakers, or MCBs, are installed in residential and non-residential buildings or are used for industrial applications. In order to allow for typical appliance inrush currents, the MCB must remain stable during a minor short-term overload. However, if the overload persists, the MCB must open the circuit after a certain period of time. During a short circuit, an MCB must interrupt the current safely in order to minimize damage. MCB tripping characteristics show a thermal trigger for overloads and a magnetic trigger for short circuits. Different tripping characteristics for MCBs exist, such as D or C, with B being the type most commonly used. For instance, a B1 rating means that the MCB will instantaneously trip currents in between 3 to 5 times the nominal current, with the nominal current being 1 amp. Inside of an MCB, the path the current is taking across the closed contacts is visible, as are the tripping components. The higher the amplitude of the overcurrent, the faster an MCB must trip. This is achieved with a metallic element consisting of 2 different metals, which are heated up by the current flow. The 2 metals are expanding at different rates while they're heating up. An overcurrent that is present long enough will eventually activate the braking element. An MCB must open a circuit instantaneously when it encounters a short circuit at several times the nominal current. A solenoid and a piston are the elements used for instantaneous tripping. A short circuit creates an instant magnetic field that moves the piston and operates the breaker. Interrupting high fault currents can result in heavy arcing. Due to magnetic forces, the arc moves through a stack of metal plates where it is cooled, split, and finally extinguished at the next zero crossing. Despite its small size, an MCB has a rather sophisticated design, consisting of 2 separate tripping mechanisms for overloads and short circuits. The quality of the materials used by the manufacturers differ widely. Therefore, some users would rather test their MCBs than simply rely on them. During testing, the MCB is disconnected from the circuit and connected to a test set. The test set generates different currents in order to simulate load conditions and fault currents. The short circuit tripping element is tested first. The overload tripping element is tested next. A stability test with nominal current completes the test for this MCB. This one is working fine. And now, on to the next one.